Is it on? Okay. We're going to solve differential equations today, but we're not going to solve them algebraically. No siree. We're going to solve them graphically. And we're going to solve them graphically using a slope field. Slope field. So the point of today is solving differential equations using slope fields. And I guess I should have put the word graphically in there. Solving differential equations graphically using slope fields. So let's do it. Let's get it on. Okay. In order to teach you about slope fields, I've got to start really early, really easy rather, because I got to tell you what. The only usefulness of slope fields is for differential equations that you cannot solve analytically. You know, like what if I gave you this differential equation, dy dx equals y, okay?
Got it.
Well, it turns out you can solve this analytically. You can multiply both sides by dx, divide both sides by y, take the antiderivative of both sides, and you can actually solve it algebraically. But so you wouldn't really want to use slope fields for something like this. You'd want to use slope fields for something like number C of tonight's homework that you guys write now. No, I guess you could solve that analytically too. But like let's say I gave you something like this. You know, don't write this down. But if I gave you something like this, dy dx equals x minus y, you as high school students do not have the capability of solving this differential equation because you can't separate the x's and the dy's and the dx's and the y's. You know, you can't get all dy's and y's on the left side and all dx's and x's on the right side. You can't separate the x from the y. So that makes it unsolvable for you guys. And so when you have an unsolvable differential equation, you can still get an equation, you can still get an answer, you can still get a solution by using slope fields where you're doing it entirely graphically, okay? But I need to have you start with something very easy. Okay, here we go. Do slope field on -3 to 3 for x and y. Here we go. Here's what I want you to do. Make a rather large xy axis and have your xy axis be numbered from -3 to +3 in the x and y direction. Next, this is going to be weird, but please just hang there with me. You're going to put a dot on every integer vertex of your graph. That is, you're going to put a dot at 1, 1, and 1, 2, and 1, 3, etc. So please put a dot at every one of those points. Every point where the coordinates are integers. So you're going to end up with a total of 36 dots. You don't have to put dots on the axes because it's kind of like already there. You know, you already know where 3, 0 is. It's right there. You don't need a dot to tell you that it's there. So 36 dots later. Next, it's time to make our slope field. You know, dy dx, that's another name for slope, right?
Yeah.
dy dx is slope. So it's telling me I've got a curve. My solution curve is one such that the slope of the curve at any point is equal to the y-coordinate of that point. That's what this is saying. This says that the slope of my solution curve at any point is equal to the y-coordinate of that point. Let me give you an example. How about at 0, 0? What would the slope of the tangent be at 0, 0?
0.
How do you know?
Y-coordinate 0?
Thank you very much. Andrew, you are so handy to have around. You guys okay with that? The y-coordinate at 0, 0 is 0, so the slope of the tangent is going to be 0. So you're going to make a little slope, and you're going to make the slope have a length of about a half. That is, your slope will go about a quarter of the way to the left and a quarter of the way to the right. Well, maybe I made mine too big, but that's okay. It's no big deal. It's all, you know. So there we go. In fact, what can you tell me about the slope anywhere along the x-axis? It's going to be 0 because the y-coordinate for every point on the x-axis is 0. So at 1, 0, make your little slopey, and at 2, 0, make a slope, and at 3, 0, make a slope. And like I said, the length of my slope is about a half. It can be more, it can be less, it doesn't matter, but you know, make it about a half, about a quarter of the way to the left to the right. So I have just laid down a bunch of slopes. Question?
No, just stretching.
Okay, stretching is good. How about at 0, 1? What's the slope of the tangent at 0, 1?
1.
You guys okay that it's 1? Because the y-coordinate is 1. So you're going to make a slope that has a length of about a half of 1. Now, what is the slope of 1? Well, you know, the slope, if the slope is 1, that's a 45-degree angle, right? Because the rise and the run have to be equal. So at every point, you're going to have to make a line where the slope is 1. That is, it's about a 45-degree angle. Rise 1, run 1. You guys okay with that?
Yeah.
What's the slope of the tangent for every one of these points?
2.
So you're going to have to estimate what a slope of 2 is. Maybe go like up 2 and over 1, I don't know. But whatever you do, try to get it where your slope is 2. Obviously, it's going to be a higher angle than the one where the slope is 1. And just estimate it as best you can. Try to get it so that the rise is 2 and the run is 1. And then the slope for every one of these points is 3, right? And on the AP exam, when they grade your slope field, all they're going to look for is if these guys are slope 3 and these guys are slope 2, these guys better be steeper slope than those guys. They're not going to take out the ruler and measure your slope, but they are going to make sure that your slope looks more steep when the slope is 3. Now, if I wanted to draw it perfectly, yeah, I'd start here and go up 1, up 2, up 3, over 1. Oh, yeah, that looks great. But anyway, just make sure that's going to be a steeper slope than these guys where the slope is 2. And then how about what's the slope at -1?
Negative.
Yeah, y equal -1, the slope is -1. So go ahead and complete this. I'm hoping that many of you see that these slopes are going to be -1, these slopes are going to be -2, and these slopes are going to be -3, and just try to make it a slope of -3, but at the very least, make sure that your slope of -3 is more steep than the slope of -2. Okay. And there's my slope field. So now, what if someone told me my initial value problem was this is an expression for the slope and it contains the point 0, 1. So I told you that it contained my solution contains 0, 1. Then I can actually draw an approximation of my solution curve. How do I do it? Well, right here, the slope of the curve has to be 1, correct? So I know my curve's going to look like this. But when I get to here, do you see how the slope has to increase to 2? And then when I get to here, the slope has to increase to 3.
Mm-hmm.
But when I get down here, like when y is 1/2 or 1/4 or 1/8, what's happening to the slope as I get closer and closer to the x-axis?
0.
Yeah, it's getting closer and closer to 0. So you see my x-axis ends up being a horizontal asymptote. So this is one solution. This would be the solution I get when it contains the point 0, 1. How about if my solution contained the point, and I'm going to use green now. What if I told you, oh no, wait, my solution doesn't contain 0, 1. My solution contains 2, -2. Well, you're just going to start at 2, -2, And to the right, you see your slope is 2, and then the slope becomes 3. And to the left, your slope gets less and less and less. And then you approach the x-axis asymptotically. This would be the solution curve that contains 2 comma negative 2. So even though I haven't actually solved the differential equation, if someone said, this is the differential equation, the solution contains 0, comma 1, what's the coordinates of the point at x equal 2? I'd say, well, at x equal 2, it looks like it's going to be about 4 or 5 maybe, or 6, you know? If I kept that solution curve going up the way it's going, you know? Then I guess 2 comma 6 or so? I don't know, you know? So it gives you an approximation, you know? Oh shoot, I should have actually put approximating, solving differential equations graphic using slope field, approximately solving. Wow, I'm so sorry. The active shooter drill that we're going to have today is totally messing me up. I blame that. I blame America's gun laws.
Good job.
But these are approximations. This isn't an exact answer. This is just an approximation. If someone said, okay, I've got the solution curve containing 2 comma negative 2, what's the solution at x equals negative 2? Well, at x equals negative 2, it looks like about 1/8 or so, maybe 1/4. 1/8 at negative 2. So you can get a sense of what your solution is without actually solving the differential equation. You guys ready to do one on your own?
Yeah.
Okay, great. Here it comes. Example number 2. dy dx equals x. Get slope field for x and y to be between, you know, -3 and 3. So -3 is less than or equal to x and y, which is less than or equal to 3. And then I'm going to have you draw 2 solution curves. Just 1 second. Oh no, just 1. Then draw solution containing 0, comma negative 1. Hey, good luck. I'm going to walk around and help you. I'm going to walk around and shoot you. I mean, good help.
Oh,
Now, well, you're doing mine? What's that? I'm so sorry, what?
Don't I have to set this up first?
No, well, I mean, you got to set up all the dots, but that slope field isn't going to look like that. Because you'll notice it's equal to x now, not equal to y. Yeah, make them dots. They're still making their dots. You guys are slow dot makers. They're still making dots. Oh my god. Okay, well, I'm just going to get a drink of water. Which is the x-axis? Okay, all right.
I messed up.
Good. Wait, what?
I gotta redo it. 'cause I-
Okay. I've yet to see anyone do anything correct yet. You're still doing dots? Oh my God. Okay, so you know the slope is going to be whatever the x coordinate is. So like at 1 comma 0, what's the slope of the tangent going to be?
1.
Yeah, so make a little slope guy that has a slope of 1.
Might it look the same as that, or would it be different?
Yeah, it'll look like that, but then the rest of your slope field is going to look different. Let me see. Oh, thank you, Angie. Thank you for being so smart. Let me see. Thank you, Kimberly. You restored my faith in humankind. Same with you. Thank you, John. Again. This is 3 lines. Let me see now. Okay, cool, cool. And what's the slope at 0.1? Good, good. And now, you know, you can be a little bit more efficient about that process now, but you're doing fine. Thank you, Andrew. Thank you for getting it right. Thank you, Alexis. You restored my faith in people named Alexis. Okay, good. Oh my, beautiful. And you know, the axis, look at those 0 slopes. If you have on the y-axis, it should be 0. Oh, you're so smart. Don't ever change. No matter what anyone says. Good for you. You're really smart for us. You got some bad slopes going on there, because you know the slope is the x coordinate, right? So the x coordinate here is positive 3. So your slope should be positive 3. I don't know what sort of insanity. Your brain is sideways. Okay, yeah, that looks great. I mean, close enough. Good for you, Ken. Yeah, on you. Unfortunately, you made an identical one, right? But you'll notice the slope is equal to the x coordinate. So like when x is 1, your slope should be 1 for all of those x's.
Follow the lines?
You just made
So I have
dy
my
dx
you knew
equal
this.
y. Thank you.
I don't know if I
Never
can do
change.
Uh-huh.
Keep being as smart as you can.
This one, yeah.
Yeah, good for you. That's beautiful. Now you're ready to draw your solution. See if I can squeeze it here. Yeah, good for you. Yeah, that's beautiful. That's by yours. Okay.
I use that with a peak.
But you know, this slope should be -1, this should be -2, that should be -3, right? Because it's the x coordinate. These slopes all look identical. So you're gonna have to take some care. Oh, yeah.
Is that what they'll record?
Yeah, it almost looks like you're drawing that way.
You're so stupid.
You're
What?
okay, because x is
Okay,
1.
here's all the
Every one of these
conversation you guys
slopes should
had.
be-
Yeah, I know, that's why I don't
It
think
should
you
have
got
negative
it.
slopes here when x is positive.
Plus, I'm pretty sure
Yes,
I
it-
have Mr.
it's a
Bean
big block.
What?
This is just another way, right? Looks like you're plugging stuff.
Absolutely, please plug in your calculator. Yeah, you can't, you don't know how to take the antiderivative out. Where's yours?
Oh, yeah.
Well, you know, your slope is the x coordinate, so at 1 comma 0, the x coordinate is 1, your slope should be positive 1, not negative 1. Okay, yeah, that's looking good. Let me see what you got. Now, at 1 comma 0, your slope should be positive 1, right? Because the slope is whatever the x coordinate is. So that should be positive 1, positive 1, positive. In fact, everywhere where x is 1, the slope should be positive 1. So right now, every single slope you have there is wrong. So I would probably just make a new slope field.
Because these are all positive slopes, so why would you?
Is it something like that?
No, you're wrong. Absolutely wrong. Completely wrong. Let me see. You started at 0 comma -1.
0 comma -1.
Oh, I thought that said 0 comma
Like
1.
the cop job?
You're so stupid.
It said
Exactly. Don't
0
tell me I'm
comma
wrong.
1. I have 0 1 written down. Okay. Okay. I just wrote it down wrong.
You're fine. Hey guys, I need to give you another one, a harder one. but are you okay that here the slope is the x coordinate? So like when x is 0, each of these slopes is 0, and you should really make it clear that you've got slopes of 0 there. Maybe use a different colored pen, I don't know.
Okay.
Here, every slope, when x is 1, every slope is 1. When x is 2, every slope is 2. Here, every slope is 3. And like I say, you don't have to be awesome with your slopes, but at least make your 3 slopes more steep than your 2 slopes. That's what they're looking for on the AP exam. These are -2, this is -3. Okay, so now it's time for me to draw the solution going through 0, -1. And this is coming here like this, and then you got your slope of 1, then your slope of 2, then your slope of 3. Okay, here coming this way, I've got my slope of 1, -1 rather, then a slope of -2, then a slope of -3. How many people got that sort of thing? Okay, good for you. Is there any question of problem on this?
No.
Okay. By the way, I could solve this differential equation, right? I mean, I could go dy dx equals x, and so dy equals x dx, and then take the antiderivative of both sides, and I get y equals x squared plus c. Whoops. Y equals 1/2 x squared plus c. You see that? And are you okay that every solution here is going to be a parabola? And every solution is going to be a parabola whose vertex has an x coordinate of 0?
Yeah.
And so now I can plug in that initial condition, -1 equals 1/2 times 0 squared plus c. So -1 equals c, and I get y equals 1/2 x squared minus 1. This would be the particular solution of that differential equation, and there's the graph of it. But the beauty of slope fields is I can get a graph of this particular solution without actually knowing what the particular solution is. Yes?
How do you know to go out so far like that?
Oh, it's just random. Someone else could have drawn it differently. I just know that when I get to this region, my slope of my tangent should be 1. When I get to here, the slope of my tangent should be 2. So I just drew my graph parallel to the slope fields. Here, I need my slope of the tangent to be 3.
I mean, yeah, I did that, but I just was wondering, because it looks like you over-exaggerated it just a little bit, but I was just, never mind.
Yeah, I mean, that happens. You know, this is an approximation after all.
That's true.
Yeah. Okay, hey, you guys ready to do one more?
Sure.
All right, here it comes.
Mine, I'm just saying mine was like x squared minus 1.
Instead of 1/2 x squared minus 1?
Yeah.
Oh, and it takes all kinds to make this crazy world. Please do me a favor and draw the slope field of, here's example number 3. And please be quicker about your dots. dy, d, I don't want to have to spend 5 minutes you guys making dots.
Wait, what's the?
X, y, and then draw solution through the point 1, 0. Okay, good luck.
Oh, it's something.
Please do the slope field for that guy. This is going to be a little
3
harder.
to 3? Negative.
Yeah, -3 to +3, just like before. And supposedly we're out of this class at 9:52. It's normal schedule, right?
Right?
Yeah. Normal schedule. And then we'll have our.
Wait a second.
I'm going to make mine gigantic.
Sleep on no man.
By the way, what's the slope of the tangent when y is 0?
Undefined,
Thank you, which makes it what kind of line?
an asymptote.
Yeah, or how about a vertical line?
Yeah.
So I just want you to know your little slope field guys are going to be vertical lines along the x-axis because the slope is undefined there because y is 0. Everything else is easy. Let me see. X and y are the same. I got slopes of 1. Right. And x and y are opposite. I got slopes of -1. Oops. And x is 2 and y is 1, it's 2, it's 3, y is 3. When x is 1 and y is a half. Now 3 halves. 2/3. 1/3. -2. Right, 2 over -1. 3 over -2 is -3 halves. -1/2, -1/3. Anyway, do you see how these slopes all line up like this? I need you to know that when you have slopes that line up like that and make a line, they always end up being asymptotes. So this ends up being the solution. If I'd given you the point 0, 1, then your solution would have looked like this. If this were the point 0, 1, you'd approach that straight line thing asymptotically. This green graph is through the point 0, 1, but I give you the point 1, 0, and that's what it's supposed to be. So are you guys getting slope field that's looking somewhat like that?
Yeah.
And it's going to just require some painstakingness.
Teachers, please, and this is a reminder, to please ensure that the video is ready for the period 2 drill. Thank you very much.
Video? There's a video?
Yeah, we're going to watch a video.
So we're not doing anything in physics?
No, period 2 is lost.
Oh.
Yeah, it's gone. Yes.
So we're not doing anything in physics is period 4. Is there anything in physics?
Well, no, actually, you're going to do the machines lab. What I'm doing is essentially the period 3 and 4 kids do the machines lab, the period 2 kids do the shooter drill, and then I'm probably just going to enter an E in the school loop. I'm going to enter like just no grade for period 2. So you guys are just not going to do it. Are we going? Bye-bye.